3.1.1, we are asked to write down the first three terms of the series. So the first thing we're going to do is we're going to write our sum. So we are given our sum, which is 12 at the top and k being equals to 3. So it's 4 into 1 over 2 to the power of k minus 1. So to find our first three terms of the sequence, or the sum rather, so we're going to say k. When k starts at 3, we're going to substitute into this problem here. It's going to be 3. So let me write it properly. So it's going to be 3 minus 1, and the answer for this one, you need to get 1. And when k is equals to 4, it's going to be 4 into 1 over 4 to the power of 4 minus 1. And the answer to this one should be 1 over 2. K is equals to 5. 4 into 1 over 4 to the power of 5 minus 1. You should get 1 over 4. So punch this calculator to find your next three terms. So the next three terms of this problem here, it's 1 plus 1 over 2 plus 1 over 4. So 3.1.2 says that calculate the sum of the series. So the first thing you need to do is we need to identify the values that we found in 3.1.1, which are our first three terms of the series, and also define whether the series is arithmetic or geometric. Then we can use a formula of that series to find the sum. Remember that our sequence, or the first three terms, were 1, 1 over 2 and 1 over 4. So if you can see here, these terms are in fraction form. Okay, that doesn't really define on whether or not it's an arithmetic or geometric. So let's first find the ratio of these terms here and see whether or not they are geometric. So T2 over T1 is equals to T3 over T2. So T2 over T1, it's 1 over 2 divided by 1 equals to 1 over 4 divided by 1 over 2. So if you punch your calculator, you will find that R is equals to 1 over 2. So we're having a constant ratio of 1 over 2. So therefore, this is a geometric series. So meaning that we're going to use a geometric sum formula. So our A value is equals to 1, which is this one here. Our R is equals to 1 over 2. So we're going to find our sum. But before we do that, we need to identify the number of terms of this sequence here. Remember that the sum that we were given initially in the problem, it was sum of to the power 12 when k is equals to 3. So to find the number of terms, we say n is equals to top minus bottom plus 1. So the top, which is this one here, it's going to be 12 minus the bottom, which is 3 plus 1. So our n is supposed to be 10. So now we have our n value being equal to 10. So we are able to find the sum of the series. So now the formula for a geometric sum is Sn is equals to a into 1 minus r to the power n divided by 1 minus r. So our a value is 1 into 1 minus our r is 1 over 2 to the power of n, which our n is 10 terms, divided by 1 minus 1 over 2. So you're going to punch your calculator and the solution should be 1.998. So 3.2, we are given this series here, which is cos of theta plus sine of 2 theta plus 4 sine of squared theta multiplied by cos of theta, where theta is an acute angle. So 3.2.1, we are asked to prove that this it is actually a geometric series. So the characteristics of a geometric series, we know that it must have a constant ratio throughout. So meaning that the ratio of T2 over T1 must be equals to the ratio of T3 over T2. So in the problem here, we are given cos of theta plus sine of 2 theta plus 4 sine squared theta multiplied by cos of theta. So as I said, we're going to use this formula here of our constant ratio. So constant ratio is equals to, so this would be our first term, this would be our second term, and this would be our third term. So T2 over T1 is equals to T3 over T2. So T2 is sine of 2 theta divided by T1, which is cos of theta, being equals to T3 is 4 sine squared theta multiplied by cos of theta divided by sine of 2 theta. So this is our R. So to write this properly, we're going to say sine of 2 theta over cos of theta is equals to 4 sine squared theta multiplied by cos of theta divided by sine of 2 theta. So what you need to note here is your double angles. So this one here, your sine of 2 theta. Sine of 2 theta, if you remember your trick, you know it's equals to 2 sine theta cos theta. And same applies to this one here. So what you're going to do, you're going to replace it with that problem here. So you're going to say this sine of 2 theta, it's actually 2 sine theta cos theta. Then you divide with your cos of theta being equals to 4 sine squared theta multiplied by cos of theta divide by your 2 sine theta cos theta. Remember this, same as this one. So now you'll be able to solve your problem. So cos of theta cancels out or divide through with that cos of theta. This cos theta divides with this one, and this one divides with this one, but sine theta remains. So meaning we're going to have 2 sine theta on our left being equals to this 4 sine theta divided by 2, right? So the 4 will divide the 2, therefore our final solution 2 sine theta will be equals to 2 sine theta. So if you can see that the left hand side is equals to the right hand side, so the ratio R is actually constant throughout. So therefore the series is definitely geometric. So 3.2.2, we are asked to calculate for which value of theta will the series converge. So remember that convergence applies when R lies between -1 and 1. And we found that in our 3.2, R is actually 2 sine of theta. So we're going to substitute this 2 sine of theta into this problem here. So our convergence, which is -1 and 1, our R being equals to 2 sine of theta. So we're going to say 2 sine of theta lies between -1 and 1. Then we divide by 2 both sides. We remain with sine of theta lies between -1 over 2 and 1 over 2. Then to find theta, we're going to divide by sine both sides, and we know that it's going to be arc sine, or the inverse rather, of -1 over 2, and theta here is going to be sine inverse of 1 over 2. We know very well that the inverse is actually 30 degrees, so it's going to be theta being less than, because this one is negative, it's going to be -30 degrees, and this one here is going to be 30 degrees. So our theta lies between minus 30 degrees and 30 degrees. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comment section below. Don't forget to subscribe to the channel for more videos.